welcome you to the Dallas Independent School District STEM Environmental Education Center virtual field trip. And we want to say a very special welcome to Leslie Stemmons, H.I. Holland, Harry Stone Montessori, and Mata Montessori. Thank you for joining us on this beautiful, beautiful winter day. Teachers, if you're watching and you have not signed up, please do so. Go to www.tiny.cc/3-5 registration. Fill out a very short form and send it in to us. The program this morning will be about the solar system. During this virtual field trips, students will identify planets in the Earth's solar system and explore models that demonstrate the relationship of the sun, Earth, and the moon. Mr. Dominguez will tell us all about the sun. Mr. Monroe will demonstrate a model of the sun, Earth, and the moon. Ms. Ram will demonstrate the inner planets and the outer planets by Ms. Ramirez. You cannot verbally ask us a question during this program, but you can send in your question to www.tiny.cc/question-answer, and I'll do my best to answer them for you. Now I'm going to stop sharing my screen, and Mr. Dominguez is going to tell you all about the sun.
Hey guys, welcome to your virtual field trip, and today we are going to focus on this big yellow thing that is the center of our solar system. Our solar system consists of 8 planets, and here's our home right here. It's pretty easy to spot. It's the blue ball right here. It's the 3rd planet from this wonderful yellow star we call the sun, and this is where we live. That's our home. But we're not going to focus on the planets today. We are going to focus on this wonderful star, and we are going to talk about why it's so important to life on this planet right here, the 3rd planet from the sun. Hola amigos, bienvenidos a su paseo virtual. Hoy vamos a hablar de esta cosa amarilla que es el centro de nuestro sistema solar. El sistema solar consiste de 8 planetas. Y aquí vivimos aquí, en este 3er planeta. Pero hoy no nos vamos a enfocar en los planetas, vamos a enfocarnos en nuestra estrella, el Sol. Vamos a hablar de la importancia de este Sol para nuestro planeta Tierra y todas las cosas vivas que llaman a esta bolita azul su hogar. ¿Ok? Vamos a empezar con nuestro paseo. Let's go. Ok amigos, antes de empezar a hablar sobre la importancia del Sol a nuestro planeta Tierra y todos los organismos que viven en nuestro planeta, quiero hablar un poquito sobre el Sol. El Sol es el centro de nuestro sistema solar. El Sol tiene una edad de 4.6 billones de años, muy joven para una estrella. Nuestro Sol es la estrella más cercana a nuestro planeta Tierra. Y la Tierra gira alrededor del Sol. El Sol es muy caliente. El Sol tiene una temperatura de 10,000 grados Fahrenheit en su superficie. Alright guys, so before we get to talking about the importance of the sun to our planet and all living things, I wanted to give you guys some quick facts about the sun. The sun is of course the center of our solar system. It's the closest star to our planet Earth. We know that the Earth spins around the sun, so it has an orbit around the sun. The sun is approximately 4.6 billion years old, which may sound old, but it's actually pretty young for a star. And finally, the sun is pretty hot. At its surface, it's approximately 10,000 degrees Fahrenheit. Alright guys, so let's talk about why the sun is so important to all the living things that call Earth home. So I'm walking outside our beautiful EEC, and as I look around, I see grass, I see trees, I'm walking towards our goats and pigs, and without the sun, there's a couple of things that would happen. We wouldn't have light energy, and we know that light energy is crucial to the growth of plants. And why is that important? Well, without plants, we wouldn't have the food to feed these goats, to feed ourselves. So everything that depends on producers would die off. And next, we have the heat energy that the sun provides. So heat energy is incredibly important. I know it's been cold, but when you step out, you feel the sun's heat, and that heat keeps a lot of animals going. I have plenty of reptiles in my classroom, and without the sun, those reptiles that are ectothermic would die. So, the sun provides us with heat and light energy. That's why it's so important to us. All right, guys, I'm back inside, and I wanted to show you guys something pretty awesome. So let me see if I can get my friend out. He is a Socata tortoise, a reptile friend of mine. Let's see if he'll let me get him. I just have to move a bunch of things around, and I'll tell you what those things are in a minute. So I've already explained to you why the sun is so important to our animal friends. Well, to all living organisms. Here he is. Here's my Socata tortoise. He's adorable, right? What happens when the sun isn't available to you? Or what happens when you are a reptile keeper and you have to keep your friends inside because it's too cold, it's wintertime. So that Socata tortoise over there can't be outside right now. So what do I have to do? Well, I have to have a setup that recreates the sun's both light energy and heat energy. So in this enclosure, I am faking the sun. The sun is so important to these animals that in order for me to be a responsible reptile keeper, I have to recreate the sun's power. So first, I have a heat lamp right here. So this lamp right here keeps my animal friend warm. And this other light over here recreates the light energy. So this is the heat energy from the sun. And this is UVB light, which is a type of light that the sun gives us. So in order for me to keep him responsibly, to keep him healthy, to keep him digesting his food, I need to have both of these things that recreate the sun's power. So the sun is so important that when I don't have it, I have to fake it. When it's summertime, he definitely goes outside, and I can't wait for summertime so he can be munching on some grass outside. But during the wintertime, I have to keep him in here, and I have to fake the sun's wonderful power. The heat energy and the light energy. Pretty cool stuff, right? All right, guys, I hope you enjoyed this virtual field trip. To recap really quickly before I let you guys go, we took a look around our environmental center and took a look at the animals that rely on the heat energy and light energy that the sun provides us. Without that big, bright yellow star, life on our planet would not exist. All right, guys. I hope to see you guys in person soon. I will see you guys next time.
Thank you, Mr. Dominguez. And a question coming in. How long will the sun last? Astronomers, these guys are a little smarter than I am, I guess, estimate that the sun will last between 7 to 8 billion years. Get your teacher to write 8 billion on the board for you. See how big a number that is. Remember, if we live 100 years, we lived a long time, what we think. Try looking at 8 billion years. And now Mr. Monroe is going to demonstrate a model about the sun, the earth, and the moon.
Good morning, everyone. My name is Mr. Monroe, and we're going to be looking at a model of the sun, the earth, and the moon. And while we're looking at this model, I want you to realize that this model is not scaled to size or the distance between the earth, the moon, and the sun. It's much, many times greater than what we have our model set up as. Well, I'm going to show you the model, and we'll talk about what's really going on. And then I've got a short presentation, a PowerPoint that I'm going to show you. But while this is going on, I want you guys to realize, I know sometimes we are under the impression we lose perspective, or we lose the thought of how large some of these, like the sun, the earth, and the moon, or how large they are to each other, or how small they are. So I want you to kind of look at that as we go through their relationship with each other. And then I want you to also be thinking about, why is it that when we look at a full moon and we compare that full moon's size and brightness to the sun, why do they appear to be the same size when they're really not? So let's look at this model just for a minute. This is the sun, and we have the planet Earth, and we also have orbiting around the planet Earth a moon. Now, this is a small part of what we call our solar system, but this is the model that we're going to be dealing with. So the planet Earth, it makes a revolution around the sun. Also, the moon makes a revolution around the planet Earth, as we can see here. Now, I'm having to do this manually because the motor in this unit is not working. Okay, now you guys notice that. Now, we're going to leave that model just for a little bit. We'll come back to it if necessary, if I have time, but I'm going to go ahead and share my screen with you guys. And I have a little PowerPoint that we're going to go over that's going to give you some additional information about the very special relationship that goes on between those objects that make up our part of our solar system. Okay. Well, let me get this down here and let's do this. There she goes. She's starting to load. All right. Earth, moon, and sun relationship. Now, this can be size relationship, and it also can be action relationship, because there is a bit of action that goes on between the sun, the earth, and the moon. You know, Earth, you saw that the planet Earth in the model, it was moving around the sun. The trip around the sun is called a revolution, and it takes around 365 days. In fact, it does take 365 days and 1/4 day to travel around the sun. And if you really think about it, 365 days, that's a year, isn't it? Okay, that revolution, it takes it, wow, one orbit around the sun, 365 days. In this image, we can see that the planet Earth, located here, travels around the sun. And of course, the numbers here reflect a little different, but it basically means the same, 365.25 days. That 0.25 days, actually, it is actually 1/4 of a day. Over here, we see that the rotation is actually the spinning of the planet Earth, and it takes what? 24 hours, which is equivalent to 1 day. Rotation is the spinning action. Sometimes we get confused about rotation and revolution. Revolution is the orbit. Rotation is the spinning action. And if we look here, there's an imaginary line that runs right through the center of the planet Earth. That is referred to as the planet's axis. Now, the Earth rotates around its axis once every 24 hours, so it's spinning. And we notice that that planet Earth in the image has a bit of tilt to it, right? And we call that the tilt on its axis. What causes the season? Well, what causes the seasons is this. Due to its axial tilt, Earth experiences seasons during its revolution around the sun. If we look here at this image right here where I've got the cursor, we see that the month of April, May, And on this side, it's March. Those are months that are actually considered to be spring, okay? Now, let's take this location right here. We can see that it's lit up a little bit because of the sun's light and heat energy. So this area right here would be in the season of spring, kind of a warm time of the year when everything is growing. And as the planet Earth progresses or moves along the orbit, we then look at the planet Earth at this point, and we can see there's a little more of the area lit up from the sun's light and heat energy. And that indicates that we're now in the season of summer. July, August, and June are considered to be summer months. Now, as the Earth progresses on its orbit around the sun, look at here, we get to September, October, and November, and that location is beginning to tilt away from the sun's light and heat energy. And that is representation that it is now the season of autumn, sometimes referred to as fall. And then as we progress further along the revolution or the orbit, we get into October, well, November, December, January, and February. In this area here, we see that there is not a lot of light being reflected off of that or being sent to that location or that area. And it indicates that we're now in the season of winter. And then it starts all over again, spring, summer, autumn, and then winter. And it keeps on going. Earth and moon relationships. Well, you might say that this is almost a size comparison. I'm not quite sure, but it looks pretty close. The Earth is a lot bigger than our moon. The moon revolves around the Earth about once every month, about every 30 days. That moon is orbiting or revolving around the planet Earth, just like we move and revolve around the sun. The phases of the moon are created by this orbit around the planet Earth. The phases of the moon are caused by its position relative to Earth and the sun. The phases of the moon include new, which is located right here. When we're in a new moon phase, there is not any light being reflected off of the moon. And you know, at one time when I was very young, I used to think that the moon had its own light source. It doesn't really. The light that we see the moon casting or giving off actually is a reflection from the sun. So from there, a few days, we move into what they call the waxing crescent moon, okay? After a few days more, we move into the first quarter or half moon. And then we move into what we call the waxing gibbous moon. And then, boy, does the moon light up there. A full moon, that means the moon is completely lit up from the reflection of the light coming from the sun. And then from there, we start losing some of the light. It becomes a waning gibbous moon. Then at this point, this part of the orbit or the revolution around the planet Earth, it is the last quarter or the half moon. And from that, we move into the waning crescent moon and then back to the new moon again. And it starts a whole new month again, and the moon starts going through its phases all over again. Now, when we talk about the moon is a small rocky satellite having about one quarter the diameter of Earth and about 1/80th its mass. So the Earth is quite a bit larger than the moon, and it has a lot more mass. It has extremes of temperature, virtually no atmosphere or life, and very little water. And when we're talking about the atmosphere, you know, our planet, the planet Earth, we have various gases in our atmosphere like oxygen and nitrogen. And oxygen is life essential, isn't it? So you can imagine if you're on the moon, you'd have to have an oxygen supply with you because there would not be any oxygen. There is no atmosphere. And then there's very little water, and water is life sustaining too. How about the sun? The sun is an average sized yellow star about 110 times the diameter of Earth. The sun is approximately 4.6 billion years old, just like Mr. Dominguez said. And it is a very young star. Hopefully, it'll continue to be a star a long time in the future, because without it, life as we know it on this planet could not and would not exist. Now, what about Earth? Well, Earth is one of 8 planets that revolve around the sun and comprise, or they make up, part of the solar system, okay? Earth, the third planet from the sun, is one of the 4 terrestrial inner planets. You'll learn about inner planets in the next session on your virtual field trip today. It is about 93 million miles from the sun. And you know what? The planet Earth is just the right distance from the sun so that life as we know it can exist. If we were too close to the sun, everything would burn up. If we were too far away from the sun, everything would freeze up. So we are just the right distance from the sun so that life as we know it exists on our planet abundantly. The Earth is a geologically active planet with a surface that is constantly changing. We have a program that we call Our Changing World out here. And boy, does it change. In fact, I've often made statements to students. Do you think by the time that you're 40 to 50 years old, that this planet is going to be the same as it is today? No, the planet Earth is constantly changing. Unlike the other 3 inner planets, Mercury, Venus, and Mars, it has large amounts of life-supporting water and oxygen-rich and an oxygen-rich atmosphere. Earth's protective atmosphere blocks out most of the sun's damaging rays, ultraviolet rays. Now, it has changed over time because we constantly are making discoveries. There have been several very smart scientists in the past, and they have come up with several theories. Our understanding of the solar system has changed from Earth-centered model of Aristotle and Ptolemy. Boy, these were some real smart scientists a long time ago, to the sun-centered model of Copernicus and Galileo. Here is a model showing that the Earth actually is the center of the solar system. Well, that's what Aristotle and Ptolemy believed in. Copernicus and Galileo believed in the sun-centered solar system. So there you have it. So hopefully you guys have learned a little bit about the relationship that is between the sun, the Earth, and the moon. And you know what? If we actually did a size comparison, let's say we're comparing the Earth as compared to our moon. Well, it'd be like a basketball compared to a ball that was about the size of a baseball, okay? As far as the Earth's comparison in size, you see this nickel? This nickel, if I was to walk over and get in the doorway of my classroom and stand there, or maybe the doorway at your house, and hold that nickel in the middle of that doorway, guess what? That doorway would represent the size of the sun, and the nickel would represent the size of the Earth. So you can see how enormous the sun would be as compared to a nickel. Well, hopefully I've been able to help you understand a little bit about the sun, the Earth, and the moon's relationship. I'm going to turn it back over to Dr. Gorman, and I bet he can answer.
Yes, Mr. Monroe, student wants to know, what is the actual diameter of the sun, the Earth, and the moon? Okay, the sun's diameter, 864,938 miles. The Earth's diameter, 7,918 miles. The moon's diameter, 2,159. So the sun is way larger than the rest of them. In fact, the sun is way larger than our whole solar system put together. And now Ms. Schramm is going to talk to you about the inner planets.
Hey everybody, good morning. It's me, Miss Ram. And like Dr. Roman said, I'm going to be talking all about the inner planets. So our solar system has 8 planets, but we are going to talk about the first 4 together. So we're going to be talking about Mercury, Venus, Earth, and Mars. And then the rest of the planets you will learn about with Miss Ramirez. So we're just focusing on these 4. So we have the sun right here. We have our Mercury, our Venus, our Earth, and Mars in this model. Now this model, once again, is not totally accurate based on size or even distance from the sun, but it is a good representation of the order and the orbit. So I have another model that I wanted to show you that I don't see very often, but I like to use because it helps me understand and remember the rotation and also the revolutions of the orbits. So we have our sun in the middle, and then we kind of have our planets on these little tracks. And of course, this is not exactly or even close to scale of size or distance from the sun, but it does help show how the planets spin and how they orbit around the sun at the same time. So you can actually drag them and move them around to see. So the closer the planet is, the shorter the orbit is. And once again, this is not the exact path, but it just goes to show you how much shorter distance the inner planets have than, say, one of the outer planets. All right, so that is that. And let me get my little presentation going. Okay, here we go. So at the end of my little section, you'll be able to identify the 4 inner planets in our solar system and their position in relation to the sun. So here we have, this is like a more to scale picture. We've got our Mercury, Venus, Earth, and Mars, and you can see our little moon right there. And you already can tell just from this picture that these planets are much smaller than the outer planets. So that's our first thing that the inner planets have in common. You might be wondering, why are we splitting up the planets? The 4 inner planets have a lot in common, and the 4 outer planets have more in common. So let's learn a little bit more about Mercury, Venus, Earth, and Mars. Boop. All right, so what do they have in common? We already said they're smaller size compared to the outer planets. They have shorter orbits, like we saw on my big circular model. They have shorter distance to travel around the sun, right? So that means their years are going to be shorter. It takes them less time and less distance to go around the sun. They have a slower spin. So that's a like longer day. Then they have no rings around them. So we don't have rings like some of the outer planets do. And they are terrestrial planets. So they are made of rock and metal. We know that our Earth is made of rock and metal and has an iron core. So these inner planets are also known as not only terrestrial planets, but the rocky planets. Okay, so let's get into it. Our first one is Mercury. Mercury is the smallest planet in the solar system. I remember growing up, we had Pluto as a planet, but now Pluto is classified as a dwarf planet. So Mercury is officially the smallest planet in the solar system. It has average temperatures about 354 degrees Fahrenheit. Since it's closest to the sun, that is the hottest planet. It also does not have a very protective atmosphere. So the temperatures vary from one side, from the day side to the nighttime side. So there's big temperature discrepancies on the sides of the planet. And being the smallest, it has a circumference. So that's the distance around. Like if the planet was wearing a belt, it would be 9,525 miles around. Okay, and then I have a little link to click And it takes about 300 years to load when I'm sharing my screen with you. But if you were to try this website on your own, in your classroom or at home, it goes pretty quick and it's fun. So this is the NASA science website. You can go on just NASA or NASA Kids, and they have tons and tons of activities and fun things to explore. Even I like it, and I'm grown up. So, all right. So we have our little Mercury here, like I said, terrestrial planet, and it has tons of information, all you would ever want to know. And you can rotate the planet. You can spin the planet, you can see everything that's going on. So anything you want to explore. So the year on Mercury is 88 Earth days, excuse me. So our year, you learned from Mr. Monroe, is 365 days. Since Mercury is closer, it has less distance to travel around the sun, so it takes less time. So 800, or I keep saying 800, 88 Earth days, dear goodness. Okay, so Mercury, because of that fact, was named after the Roman god of speed because it goes around the fastest, right? All right, and you can also learn about the distance from the sun and how many moons. So Mercury has 0 moons. All right, so let's learn about the next planet, Venus. Venus is the hottest planet in the solar system with average temperatures of about 857 degrees Fahrenheit. That is extremely, extremely, extremely hot. So just for reference, in our summers, it is about like 100 degrees in Texas, right? So in North Texas, we get summers where temperatures are a little over 100 degrees, and we're really, really hot. If you were to bake a pizza in the oven, it would be at like 350, and Venus is at 857. So that is extremely, extremely hot. Definitely intolerable. So it's called a greenhouse planet, and that is has to do with why it is so hot. So Venus's atmosphere is thick and toxic. There's tons and tons of toxic gases that trap that heat into its atmosphere. So it is close to the sun, but also all those toxic gases trap that heat in. If you've ever visited a greenhouse, or maybe some of you have one in your backyard or know someone who has one in their backyard, greenhouses here on Earth are built out of glass or plastic, and they take in the sun rays and trap kind of that heat inside to help plants grow during winter or colder times. Well, Venus, the whole thing is like one giant greenhouse that's kind of out of control. So it's called the runaway greenhouse effect, where all those gases just keep building and building and building, and it just stays hot, 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 and never really cools down. Something else interesting about Venus is it has a longer day than its year. So remember, our days are caused by the spinning of the planet. So it takes longer to spin around than it does to orbit around the sun. So its spin is longer than its revolution. So it has a longer day than its year. And it has a circumference of 23,000 miles, 23,628 miles. That is how long it is around. And that's very similar to Earth. We'll get on Earth stats next, but it is often called the Earth's toxic twin because of all those toxic gases and its similarity in size to Earth. So Venus's year, like I said, it's closer to the sun, so it's got less distance to travel. So instead of our 365 days, the Venusian year is 225 days. And it has 0 moons, and it is named after the Roman goddess of love, Venus. And like I said, you can see more interesting facts here. One I'm reading right now is talking about the greenhouse effect, but also Venus spins slowly in the opposite direction from most of the planets. So it has that longer day than a year, and it spins in the opposite direction. All right, learn something new. All right, let's see. Next planet is our home, Earth. Earth is known as the blue planet, and you can tell why, because look at all that blue on our beautiful little planet. Our planet is 71% covered, the surface is 71% covered in water. And you might be thinking, wow, that's a lot of water. And you may have heard things about like turning off the faucet when you're brushing your teeth and how it's important to conserve water. Well, now you know that 71% is water. So why do we have to conserve water? Well, if you look at the globe here, we've got all of that ocean water, and we cannot drink ocean water. Ocean water has salt in it. So salt water is not good for us to drink. It can make you throw up, it can make you sick, and it actually dehydrates you. So we only have about 4% fresh water. So that's why it's really important to conserve water, because only some of the water on Earth is able to process and digest. So it's really important to protect our water sources and conserve water. On Earth, our average temperatures are about 60 degrees Fahrenheit, which is quite lovely. So it's very tolerable for life. Earth is the only planet known to us to have evolved life. So we're the only planet that has living things, plants and animals on it. And that is very special. We have not found any other planet in the universe that has officially life. So a lot of times scientists are trying to explore space and see if there's other life forms somewhere else. But so far, just here on Earth. And Earth, I said, was like the twin of Venus. So it's 24,901 miles circumference. So that's very similar, only about 1,000 miles different than Venus. And let me click this little thing. Here it goes. And like I said, we have a year of 365 days. That's how long it takes for us to travel around the sun. And here we are. And we know that we have one moon. And let's see, where can I find us? All right, they are having their nighttime. Where are we? Whoa, I almost passed this. All right, there's the Americas. So we are around here. Boop. There we go, in Texas. All right, so next one is Mars. And Mars is a very interesting planet. I could go on for about 300 years about Mars. There's been a lot of space exploration projects going to Mars, a lot of missions with rovers and everything sent over there to see if there's any proof of water or potential for life or a history of life on Mars. So like I said, Earth is the only one so far, but scientists are constantly trying to figure out what's happening on Mars to see if one day people could inhabit Mars or move there. So Mars is known as the red planet because of that dirt and rock that is that pretty red color. The average temperatures there are negative 81 degrees Fahrenheit. So that is very, 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 very cold. So we're not moving there anytime soon. And plus it's a long way away. The atmosphere is also made of carbon dioxide. So when we breathe air in, we breathe in oxygen and we breathe out carbon dioxide. So carbon dioxide is not something that we are able to breathe in. It's what we kind of produce as we breathe. So the atmosphere is not conducive for us to breathe there. There's less gravity on Mars than on Earth. So your pull towards the center is going to be less. So if you weigh 100 pounds here, you would weigh about 30 pounds there. So walking would be a lot different. Your body would feel a lot different if you were walking on Mars. And Mars has a circumference of 13,263 miles. So it is much smaller. It's smaller than Earth. It's about halfway between the Earth and the moon. Okay, so let's see what's happening with Mars. And like I said, this is not an ad from NASA's website, but if you're ever doing a research project on Mars or interested in your free time to look at Mars, there's information on all the different missions, all the different Mars rovers. There's even things you can print out and build your own versions of the Mars rovers and everything like that. So it's really cool. And Mars has 2 moons. And it is named after the god of war. And let's see, their length of a year is 1.88 Earth years. So actually not too different, I guess. All right, and then let's see. Doo-doo-doo. All right, that's all I have. So I'm gonna send you back to Dr. Gorman for any questions, and then Ms. Ramirez is going to tell you everything you need to know about the outer planets. Thank you so much, and I'll see you next time.
Thank you, Ms. Ram. And question is, what is the largest and smallest inner or terrestrial planets? The Earth is the largest, almost 8,000 miles diameter. Mercury is the smallest, with a little over 3,000 miles diameter. Now, Miss Ramirez is going to tell you all about the outer planets.
Hello, my name is Miss Ramirez, and in this segment, we're going to be learning about those outer planets. So I'm going to share my screen with you guys, and we'll get started. And I do have a couple of diagrams that I would like for you guys to look at really quick. As soon as it loads, there it goes. So make some observations about these two diagrams and think about what are some limitations of these diagrams. So when I say the word limitations, that means how are these two diagrams maybe not a good representation of the real solar system? Also see if you can compare and contrast the inner and the outer planets. So you guys talked about these first 4 inner planets with Ms. Schramm. In this segment, we're going to look at the last 4 outer planets. And a good way to remember the planets in order is by a very simple sentence, and that is, my very excellent mother just served us nachos. So if you can remember that sentence, then you actually know all of your planets in order from the sun. And we're going to be focusing on the last 4. These are also known as the gas giants, and they're given that name because, as you can see just by looking at this diagram, they are much larger than the inner planets. So just by looking at this diagram, you guys can probably think of some other differences between the inner and the outer planets. And again, feel free to pause if you would like time for students to discuss maybe some differences that you noticed. But I'm going to go ahead and go right into it. We talked about the size. That's the most obvious one. The inner planets are smaller. The outer planets are much larger. But also look at the location. The outer planets are much further away. So what do you think that can tell us about their temperature? So because these outer planets are so much further away from the sun, they are much colder than the inner planets. Also, because they are further away from the sun, what do you think that can tell us about their revolution? So remember, a revolution is the amount of time it takes for a planet to go all the way around the sun. Well, because these outer planets are so much further away, it takes them much longer to complete a revolution or an orbit. So let's look at some other commonalities between our gas giants. All of our gas giants, of course, are going to be larger than the inner planets. They're going to be colder because they're further away. They revolve slower, again, because they're further away from the sun. But oddly enough, they actually rotate super quick. So remember, rotate is when a planet spins around its axis. That gives us day and night. So the days on the outer planets are actually super short. All of the outer planets have many, many moons compared to the inner planets, and all outer planets actually have rings. I know we typically think of only Saturn, but all of the outer planets have rings. They're just not as pretty or as noticeable. And then we have a dividing line. There's what's called the asteroid belt, kind of divides the inner planets from the outer planets. So what we're going to do next, we're going to go to a website called solarsystemscope.com, and we're going to get a virtual look at some of those planets. So let me share that with you. So we're going to take a look at the planet, the gas giant that is the closest to the sun. And what do you guys think that is? So let's see if we can find it. So if we remember our acronym, it is my very excellent mother just. So just stands for Jupiter. We're going to go fly over to Jupiter. Jupiter happens to be the largest planet, and it is a very cold planet and has lots of wind and clouds. It also has what's called the Great Red Spot, and we'll see if we can find it. Here it is. It is a giant storm that's actually bigger than Earth, and it's raged for hundreds of years. It has a very short day, only about 10 hours. So remember, it spins super fast. And it has a very long year. So it takes about 12 years for it to go all the way around the sun. And it does have a very faint ring system, and it has over 75 moons. So that's Jupiter. What do you think is our next planet? Hopefully you guys have found it. We have Saturn. Saturn is our second largest planet. It's the one with the most prettiest rings. And those rings are made out of thousands of ringlets that are composed of ice and rock. Again, it has super short days, so it spins really fast, and it has long years. It actually holds the record for the most number of moons. It has 82 moons. So we have my very excellent mother just served. Our next one is us, which stands for Uranus. Let's see if we can find that one. Uranus is a weird planet because it actually rotates on its side like a barrel. It also is a ice giant, so it's super cold here. It also has very faint rings, and it's blue because of a special gas called methane. And it has a twin planet, Neptune. They're called twins because they're very similar in color due to that methane. Neptune is super cold. It has lots of heavy, super fast winds, and it has short days as well. But this has a very long year. So it takes 165 years to complete one orbit around the sun. It is our windiest planet, and distance-wise, it is 30 times as far from the sun as Earth is. So what we're going to do next, I know that was a quick little brief introduction to those outer planets, but see if you guys can identify these 4 outer planets based upon the characteristics that we just discussed. And again, feel free to pause the video to allow time for students to identify and discuss those characteristics, but we're already out of time, so I'm going to give it back to Dr. Gorman to answer any questions.
Thank you, Mr. Ramirez. The question is, what is the largest moon in the outer planets? And it is Ganymede. The moon of Jupiter is the largest moon in the solar system. Ganymede has a diameter of 3,275 miles. That is 1,114 miles larger than our moon. Thank you again, Mr. Ramirez. And now I'm going to share my screen. During this virtual field trip, students identified the planets in Earth's solar system and explored models that demonstrate the relationship of the sun, Earth, and the moon. Mr. Dominguez talked about the sun. Mr. Monroe demonstrated a model of the sun, Earth, and the moon. Ms. Schramm covered the inner planets. Mr. Ramirez, the outer planets. Thank you for joining us. If you would, go to www.tiny.cc/3-5 feedback, fill out a very short form. You guys have a great rest of the day. More importantly, have a great rest of your life.